Yeah.
Perfect. Thank you very much. All right. So good evening, everyone. My name is Andrei Kaminsky, and together with Willie, Naveen, Martin, and Ilza, I am co-organizer of this event. No, DevOps is really about breaking silos. Basic agility is really about breaking silos between the business and development. What DevOps does, it extends it further by adding operations or security or machine learning, AI, and anything else. So there is really about breaking silos between those different functions. But here's a paradox. Because from one side, we break the silos within the organizations, but that's not exactly how we build software. As a matter of fact, the trend is right now to do the opposite with microservices and where we are implementing the single functionality. But to reduce those dependencies, we are using techniques like loosely coupled architectures, for example, containerization and orchestration. But yet we still face issues with brutal interfaces, and we have to address them somehow. How to future-proof our systems so they are more resilient, more adaptable, and safe to operate? Now, the topic that Alex will be talking about is pretty intriguing. The entire concept of bureaucratic system approach sounds very interesting, and I'm really wondering to get a little bit more in depth. I've seen the original presentation that Alex did about a week ago or so. So I know it's really very good and thought-provoking. So I'm going to hand over to Ilse to introduce our speaker today. Thank you.
Thank you, Andre. Hello, everyone. My name is Ilse de Bishop, and I'm also co-organizer of the DevOps Vancouver Meetup. So welcome. Now, before we begin with our main attraction, a few housekeeping rules. As you would probably have noticed, this session is being recorded, and it will be shared on our Meetup YouTube channel in a month's time. When not talking, please mute your microphones. You can either ask your questions while during the talk, either by asking Alex directly or by putting them in the chat. We will be monitoring the chat. And also, please remember that we need your actionable feedback to improve the meetup and your ideas for future sessions. And now, for our main attraction, I'm very happy to have the privilege to introduce Alex Bunarczyk, who will be speaking on the topic of how I learned to develop software like a bureaucrat. Alex is a software development professional known for his innovative approach to technology and digital solutions. With a career spanning several decades, Alex has established himself as a respected figure in the tech industry, especially in software development. He possesses a deep understanding of various development methodologies, making him proficient in creating robust and efficient software solutions. Alex's dedication to his field is evident in his continuous pursuit of knowledge and his enthusiasm for embracing new technologies. Outside of his professional pursuits, Alex is passionate about music, particularly playing the guitar. He also has a keen interest in high-quality audio experiences and enjoys collecting vinyl records. This combination of technical expertise and artistic inclination makes Alex a unique and multifaceted individual in the tech world. Alex, the virtual floor is all yours.
Thank you, Ilse. Let me see if I can share my screen. Should be up here. And please let me know if you can see my...
Yes, we can.
Okay, excellent. Thank you very much. So this is a great honor for me to be invited by Andre. some of you may know that I worked under Andre's leadership and supervision for about 3 years. And this was the highlight of my career so far. I learned so much from Andre. And a lot of the ideas here, I would say I've carried over listening to Andre, either when Andre speaks publicly or leading the teams, or we had our one-on-one chats as well. And that was very inspiring. So credit where credit is due. A lot of these things I credit to Andre as inspiring me, leading me, and encouraging to really, go the extra mile, pushing the boundaries, breaking silos, and coming up with some out of left field ideas, which, we can always try out and see if they work. If they don't work, we can try something else. So that level of mastery and something that Andre taught me, the approaching things with a beginner's mind, not with a hardened and, premeditated or preconceived notions, is, I believe, what really helps us in our profession to advance, to make things better, and not to just sit on our laurels. So again, thank you very much, Andre, for this opportunity. Super excited about this. It's a big honor for me. I appreciate your long standing leadership in the DevOps community here. Very inspiring, and I hope I can contribute something today. About this talk, as I mentioned, it's going to be quite dense, and I therefore encourage people to stop me and ask me if I'm doing something that's not clear. I really try to make it more entertaining, but I'm afraid the topic is such that I have to necessarily load a lot of text. And I know that reading off the slides is not the best presentation technique, but I really couldn't find any other way. I will have to be reading off the slides. There won't be any hands-on coding or anything like that, because that would warrant a bigger workshop. So here I will just try to go through these slides, present those ideas, and of course, as I mentioned in my previous talk, when I was, when I mentioned to my colleagues and my friends that, I have this talk about how do I learn to develop software like a bureaucrat, that always, facilitates kind of negative reaction. Like, what, like a bureaucrat? That's not, why would you do that? Bureaucracy is not something to strive for. It's dull and drab and boring, and it's not creative. Why would you do that? So I know it's a bit controversial topic, and I'll try to explain what I mean by that. So without further ado, let me just quickly say a few words about me. I have started developing software professionally in 1990, so it's kind of coming 34 years doing it full time. And along the way, I made all possible mistakes. 34 years is a lot of time. I've been in various roles, and we learn from our mistakes. The biggest mistake I've actually ever made was actually to measure once and cut once. And that's something that I'm just trying to move this. Okay, sorry, 1 second. All right. So, oops, sorry. First, before we start, let me talk about what problem am I trying to solve here. I'll go back to, I've been working with a lot of people, a lot of teams throughout my career. But if I try to summarize, what do people complain about the most? Both people in the trenches and people who are leading. It's three things that I kind of boil down to. One is everybody's complaining about the pressure to deliver. Oh, there's so much pressure to deliver, and it's kind of making this job very intense. Also, the lack of technical skills. Our software is really demanding, and you need a lot of technical skills. It's hard to get all those technical skills under our belt. And lastly, the lack of domain knowledge. So we are going from project to project and different domains, and it can cause a problem. So this is what I find that people complain about the most. But to me, these are mostly symptoms, not the causes. And yeah, it's okay. It's okay to complain about symptoms, but if we attenuate or remove the symptoms, then the causes still remain. That's not going to be the solution. And so we need to find the root cause. And this is what I'm trying to do today, is hopefully get to the identified within the domain of building business applications, business systems. I'm not going to be talking about issues with gaming and other more specialized software development, but the mainstream, the bulk of software development is basically automating paperwork, workflow, all these administrative tasks, etc. So let me first start with the short history of human species, which I believe is the history of technology, because in the early pre-technological days, human generation lived pretty much the same way as all previous human generations. That's similar how animals live. So long as some species does not get extinct, each generation lives the exact same lifestyle as any other generation of the same species. But humans are different, because we are prone to inventing things that our ancestors never dreamed about. And we do it by focusing on technological advancements. So from the, inventing the fire, the wheel, the printing press, et cetera, we're advancing as a species by focusing on technology. And therefore, that's why I think our history is kind of determined by technology. So Alfred North Whitehead said that civilization advances by extending the number of important operations which we can perform without thinking of them. So how do we perform important operations without thinking of them? There are two ways to do it. Actually, we outsource them, and then there's two ways to outsource them. One way would be to create organizations who are responsible for carrying those important operations. Another way would be to automate those important operations by utilizing machines. And so of the two ways, automation appears to be more cost-effective, and hopefully it's more predictable and more convenient. It is for that reason that the progress of our civilization always seems to lean toward more automation. However, automation means rigidity. So if we are intending to automate some process, then we can only do it if it's repeatable. If the process is not repeatable, it's kind of impossible to automate it. And if some process is repeatable, that means it's a rigid process. So when we automate such rigid process and virtualize it, then any future changes to the actual process will be ignored by the automated equivalent. And that means our automation is not useful in the long run. It's useful for the time we have automated something that worked a certain way, but then things change, right? And there are precious few things in this world that don't change. And most of the time, what seemed like a solid, unchangeable thing, we see quickly turns into a moving target. And so our automation is not valid anymore. Its rigidity becomes a liability, not an asset. Automated systems that are in use today are expensive to maintain. I don't think I need to defend that argument. We've all been in this situation. This is our career where we are constantly busy maintaining, and it's expensive. Costs a lot of money and time and effort. Because automated systems need to be constantly modified to accommodate the unstoppable onslaught of the changes that occur in our world. And we see that automated systems are therefore brittle. And there's the saying, digital rot never sleeps. Even if everything is, all the ducks in a row and everything is set up properly, we still get those unwanted middle of the night calls. Something starts breaking, somebody forgot to renew the SSL certificate or some other thing. Things keep shifting, right? It's a house of cards. And, it's expensive to maintain. So when we think about what causes the brittleness are dependencies, because parts of the system depend on some other parts of the system, and they in turn depend on some other parts. And those dependencies then harden into a tightly coupled brittle surface or surfaces. And then as soon as we start applying the pressures of unavoidable changes, the brittle surface begins to crack, and then more often than not, we see that it quickly turns into a serious breakage. So, things are brittle and are expensive to maintain. So I'll give you one example from this person, Brian, whom I know. He complained a few weeks ago that, hey, I had, he was complaining about Google. And he said, hey, Google, you should be a better steward of your APIs, because there was a Google GitHub Actions /release please action API, and then they renamed it to something else on Friday, and that broke thousands of workflows. If that's not bad enough, they didn't even update the documentation, and nobody knew about this change. Things just started breaking. And, that's something that keeps happening, and not only happening because we are depending on some third-party services, but also in-house. We have different parts of our system, and they kind of depend on each other, and then different teams or different departments do evolve at different pace, and then somebody needs to make some changes, and all of a sudden, what used to work stops working. So that's the brittleness I'm talking about. So the goal of good engineering is, or should be, to actually avoid situations like this with the Google API. If we are engineering our system properly, then we should strive to avoid such breakages. Because things keep changing not only at a brisk pace, but also they change without us being notified of the change. It just hits us when you least expect it. We cannot build robust, reliable systems if our solutions keep breaking, because previously agreed upon ways get modified without us being aware of the change. So this is what I would say is the root cause of all these symptoms: constant pressure to deliver and inability to reach technical excellence and lack of domain, because we're too busy maintaining something that used to work. And therefore, all the time is eaten up by these chores, by these things that used to work and now they broke down. And then we feel the pressure from stakeholders saying, okay, what's going on? I need to deliver. Why are you going back and reworking something that used to work? And so to try and remedy that or deal with it, we need to think about future, as Andrea said at the intro, how do we future-proof this automation? Yeah, it's beautiful to have automation, but we see that it's not future-proof. Somebody coughs and things stop working. That's the bane of our profession. That's something that is really haunting us and giving us, as professionals, black eye. And I don't blame the stakeholders who come to me and say, Alex, well, what's going on here? Like, your team, you gave us this beautiful thing, and then something happened. I don't know what happened. All of a sudden it breaks down. Customers are screaming. Can't you guys get your act together? And I think it's a fair question to ask, because we are being paid handsomely. So a future-proof automated system would be a system that will not stop working as expected if the rules that are governing the system change. It should be able to not break. And we know that the rules are going to change. So the question is there such system in existence today, or am I just daydreaming and kind of making things up? But Alex, let's be real. On the real side of things here, that's how things are. We just, shrug and say, okay, well, we need to accept the reality. So I would say that such system exists, and I'll go do my personal experience. Recently, I was planning to travel, so I realized that my passport needs to be renewed. So I went through a passport renewal process, and I think in Canada, it expires after 10 years or something like that. So anyway, let's walk through that. How did the renewal go? The first thing I did, I had to search online for the nearest passport office here in Vancouver. Either White Pages, Yellow Pages, Google, what have you. Then, secondly, I had to actually travel to the office. I had to hop on the bus, train, drive, park, etc. The third thing I had to do, I arrived there and I inquired, like, hey, what do I have to do to renew the? There's a concierge or somebody at that office. And then they actually informed me that I should pick up the passport renewal brochure that's available on display here. Okay, I picked it up. Now I had to examine the brochure. What does it say? I learned what the requirements are for the renewal. Then I followed the instructions. I procured necessary photos, documents. I filled out the form. I brought it back. I paid the fee, and then I waited. So basically, that's the procedure in a nutshell. What are the takeaways from this process? To begin the process, we need to obtain the entry point, which is basically the address of the government service for renewing passports. Then, once we make it to the entry point, we need to pick up the instructions found inside the office. Then, we need to follow the instructions that are printed on the passport renewal brochure and provide all the necessary artifacts, which are explained there. Once all the instructions have been fulfilled, we must submit the request, pay the fee, and wait for the response. Bureaucracy, that's bureaucrat. But I would say that process is not brittle. Why is that? The reason, sorry, my slide is slow to load. Because all the information that is necessary for successfully completing the transaction is available at the government office. And the information is applicable right now. And by making an effort to go straight to the source, to the government office, I avoided the risk of acting based upon some stale information or obsolete information, because it was a risk of I would be wasting mine and everybody else's time and money. Waiting for the last slide to load. But had I relied on some prior knowledge of the passport renewal process, because I did renew it like 9 years ago, and I may have remembered, oh, I know what does it take, but that information might have been stale, and I might have missed on the latest changes in the government regulation, which indeed something changed. There's always some tweaks and changes, and if I was acting on my memory of the previous successful renewal, that would be a bit naive and foolhardy. So I call this process piecemeal discovery. Not I, everybody calls it that. We can call it. So I think it is possible to design an automated system in such ways that when the conditions in one part of the system change, the dependent parts of the system don't have to be changed. It is possible. So, because if they have to be changed, that means we need to, and we're not notified, that things will break. So how do we do that? How do we design something that when one part changes, the other part doesn't have to change? And I would say we emulate the bureaucratic procedure. That's basically why I chose to say how I learned to develop software as a bureaucrat, learning from the bureaucratic approach. And quickly, just want to review the producers and consumers. In this case, the government office is the producer of passports, and the citizens are the consumers of passports. And in between the producer and the consumer lie the rules. And these rules are prone to change, as we've seen. The biggest challenge is how do we protect the consumers from having to learn about the rules? And then when acting on the learned rules, they may find that, oops, the rules have changed. And then there's a breakage. How do we avoid making our automated system brittle? This is the central question of this presentation, and I also believe of our profession. So I want to quickly review how would piecemeal discovery work online. Previously, I described how it works in the physical world. I go there in person, etc. But let's say the government now enables us to do it online. So step number one, somehow obtain the online address of the government passport renewal service, a virtual office. Similarly, I could look at some catalog or Google it, searching online. The second step would be, once I get the URL, I click on the hyperlink, takes me to the online virtual office. Step number three would be, once in the online office, I search for the online brochure of passport renewal. When I find the online brochure, I dedicate some time to study the requirements, passport renewal. And then step 5, I would obtain all necessary artifacts, 2 headshots, anything else specified in instructions. Then I would fill out the online form. I would attach the artifacts, click on I accept terms and conditions checkbox, submit my passport renewal application. And lastly, I would have to process the payment somehow before I could expect the government officials spring into action and start working on renewing my passport. This is how I would describe piecemeal discovery online. This is something, a very important concept that I would like you to try and memorize, called in-band process. What it means is all the information necessary for successfully renewing my passport was supplied by the system I was interacting with. There wasn't any need at any point during the above 7 steps for me to go and obtain some additional information from some other resource. In-band process means that the information, the knowledge of what needs to be done is self-contained, self-explanatory, and there is no need to seek counseling from any third party in order to be able to successfully reach the goal. In other words, I didn't have to call my accountant. I didn't have to call my lawyer. I didn't have to call my MP representative. Everything that I needed to do to successfully reach my goal is available in there, in this interaction with the system. This is, in my opinion, a very resilient approach. By relying on information that travels with the response, we, the clients, do not have to prematurely bond with any prior information knowledge. Like I said, I had some prior experience, but I better approach this with a beginner mind, as if I never done it before. It's completely blank, stateless. I open myself to this interaction. I don't bring any preconceived notions like, oh, hold it, wait a minute, before you, who cares? Right now, I want to reach my goal, and I'm only open and sensitive to the direct information I'm getting from the service I'm interacting with. The set of instructions necessary to be able to process the response is contained in the response itself. So it's very significant. And also, the information, the instructions are obtained at the last responsible moment. It's not like I went and maybe a month ago, I downloaded something and I kind of saved it somewhere and then I'm acting on it. No, because in the meantime, things have changed. So I want to do it in real time. I'm interested in the freshest information, freshest set of instructions. That means that when the knowledge needed to process a response changes, the client does not break, because I'm not squirreling away some prior knowledge. And as I said, the approach is to act with a beginner's mind, with open mind, and blank slate, and interact with the system as it is right now. Okay. Trying to load the slide. I don't know why is it. So technically, this is what we call late binding. We are binding with this interaction as late as possible. And another thing I want to mention is this mantra that I like to say, that we don't really have a crystal, and we cannot predict what is going to change and when is that going to change. Therefore, again, blank slate, open mind, beginner's mind. Let's cross that bridge when we get there. Let's not have grandiose plans and then we don't know what's going to happen in a few weeks, few months' time, etc. So let's look now into real automated systems, how to deal with those systems. We pretty much know that if we automate a system based on today's rules, it's inevitable sooner or later in the future, some of those rules will change. Very unlikely that everything stays put for a long time. When that happens, the automated system will break, of course. And the way we tend to deal with unavoidable breakages is we make an effort to design our automation in such ways that will enable us to do swift and painless and hopefully risk-free future changes. So the maintenance, right? So we're trying to design the system so it's easier to maintain. Basically, what that means is by now we have been accustomed to rolling with the punches. And we know we're going to get punched in the face. So we're like, okay, so what is the least traumatic way we can deal with this punch in the face? But my point is, we don't really necessarily have to live like that. We don't have to say, you know what you're going to do? You're going to get punched in the face. So let's find a way to kind of alleviate the pain. But rather, why don't we think about automating this piecemeal approach that we've seen works in real life, as well as works in online world with the bureaucratic system. So far, we've seen that piecemeal approach works well with human users. But the question here is, can machines be designed to take advantage of the piecemeal approach? This is the core question here. Why? Because machines are rigid. Unlike humans, machines lack agency, and are therefore devoid of goals. We always have goals. That's how we live. Machines have zero goals, as far as I know. It is for that reason that we need to preload the knowledge describing what to do into machines. And this preloading of knowledge is basically programming. We write code, and that code is prior, designed and preloaded, and the decisions what to do are kind of preemptively, upfront, hardened, and we load the machines with that knowledge. And without that prior knowledge, machines would not be in a position to make the decision what to do next. Machines don't care because they lack sentience. And we are sentient beings who have agency, and we have goals, and we are acting. We are making decisions. So can we overcome the machine rigidity? This is a serious barrier, right? It seems like a daunting or even impossible challenge to let machines make decisions at the last responsible moment without having preloaded or previously agreed upon rules and knowledge. However, if we do not enable machines to make decisions at the last responsible moment, then we will forever be stuck in the world of rigid, brittle, easily breakable automated systems, as we've seen, and we're stuck today. We maintain the system. There is, however, one way that I'm aware of that could enable breaking out of the rigidity prison, and that is called REST. So I'm pretty sure you know what REST is, but let's quickly rush through. It stands for Representational State Transfer, was defined 22 years ago by Roy Fielding in his doctoral dissertation. Okay, so the state transfer implies that a resource representation, say in this case a passport is a representation, it could potentially change its state from expired to renewed, or could change its state to something else like invalid or canceled, etc. Right? But the resource can change its state via its representation. That's what REST is all about. So what is representational in there? A passport represents the citizen status with regards to citizens being able to travel abroad. If resource representation of someone's ability to travel abroad status is expired, then that status is invalid, meaning the citizen is not fit for traveling abroad. When the resource representation transfers its state to renewed, the underlying resource, the passport of the citizen who is clear to travel abroad, is updated. That's what kind of REST is all about. How is REST implemented? There are 6 constraints that enable REST to be implemented. One is the client-server architecture. Of course, REST is an architectural style that is applicable on the network. It is stateless. It allows caching and must have uniform interface, is a layered system, and number 6, loading up, come on. Load on demand should be. Okay. I apologize for this hiccup. I don't know why is it all of a sudden choked. Oh, yeah. Number 6 is allows for code on demand. Okay, let's quickly go through some of those. Client-server constraint. REST is an architectural style only applicable to systems running on a network. REST describes both the client and the server as they communicate on the network. The stateless constraint is that every request should encapsulate all information necessary to respond to that request, with no side state or context stored on either the client or the server nor elsewhere, no out-of-band knowledge needed. This constraint ensures simplicity, which in turn ensures robustness and resilience. Caching constraint. Any future requests for the same resource representation should be cacheable. This means that there must be explicit information on the cacheability of responses for future requests on the same resource representation. And the uniform interface constraint is the central feature, and I will quote Roy Fielding from his dissertation. It's a central feature that distinguishes the REST architectural style from other network-based styles. Its emphasis on uniform interface between components. In order to obtain a uniform interface, multiple architectural constraints are needed to guide the behavior of components. REST is defined by 4 interface constraints: identification of resources, manipulation of resources through representations, self-descriptive messages, and hypermedia as the engine of application state. Let's quickly go through these. Identification of resources is universal resource locator, the URL. It's simple because it's guaranteed unique, which means it removes any possible ambiguity. So that's one constraint. Manipulation of resources through representations. A single resource can be represented in many, maybe innumerable ways. It can be represented as text, as pictures, as markup language, etc., etc. It is possible to use media type to signal to the server what kind of resource representation is acceptable. Self-descriptive descriptive messages mean that everything necessary for deciding what is possible to do must be contained in the message itself in the form of hypermedia controls. This is the in-band knowledge. Client does not have to know anything ahead of time. No out-of-band knowledge is required, which again enables the client to be blank slate, beginner's mind, no preconceived notions. Hypermedia as the engine of application state, or HATIUS as the acronym, is made possible by self-descriptive messages. A self-descriptive message enables the calling client to discover what capabilities are available on the server. The calling client can then decide what action to take. It is the uniform interface of the hypermedia that provides the ability to control the state of the application, and that capability is the engine that drives the interaction between the client and the server. So one important thing to distinguish here, because sometimes I see there's a little bit of confusion, is something called remote procedure call, or RPC, but HATIUS is not that. And we at large, we have been trained to implement some functionality. Or if we're building an app, we're doing it by calling various procedures, right? You can either call them locally or remotely. And to call a procedure, we must know beforehand not only the location of the code that implements the procedure, but we also need to know the signature of the procedure, including the parameters. This is the API, right? As well as the type of the return values. And if we don't know that, we cannot call the procedure. And since APIs are subject to inevitable change, the brittleness is controlled by imposing the versioning of the functionality or API. So we know that something is going to change. That's inevitable. And so to avoid breakages, anytime we make a change, we actually spawn the new version. But HATIUS does not function like that because there's no versioning of the functionality in HATIUS. So when we look at RPC, remote procedure call, we see it's kind of representative of the early binding or tight coupling. Before a client code can prepare the context for calling a remote procedure, the authors of the code, like if we are writing this code, we must know everything there is to know about the signature of the remote procedure, as well as the type of any returned values. This is early binding, meaning we need to obtain out-of-band knowledge about, okay, what's the name of the procedure, or API, what is the payload required, blah, 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 what is the return type of return value. The client and the server are tightly coupled, and that is making the arrangement brittle, because if some changes, breaks. So how can we make sure the calling client doesn't break? This is the challenge, because there is no way for the calling client code to detect that the signature or type of return value of the call procedure has changed. It only learns upon calling, right? Therefore, the onus is on the server to play nice and not let the breakage happen. And it is customary, and often it's contractually obliging, to maintain backwards compatibility by versioning the API. In other words, if there's a certain functionality built and offers an application programming interface, the clients get used to it, get bonded with it, right? And they seem to be working fine. Now something changes. The contract says, okay, look, don't change it by breaking this, but create a new version, and then we can, if we like it later on, we can upgrade to that version, but for now, please maintain backwards compatibility. Therefore, nothing will break. So that's the strategy for making sure the calling client doesn't break. But this increases the bloat, and this adds to the accidental complexity. And accidental complexity is, in my opinion, by far the worst problem that's plaguing software development. That's just a big problem. Because why? Because inventory in software is waste. Inventory may be an asset in some industries. I'm not sure which ones, I don't know. But in software, inventory is always waste. Maintaining multiple versions of the same app is, in my opinion, insanely wasted. And we all seem to be doing it. We're doing it because we want to maintain backwards compatibility for the simple reason. But this, I think, is meaningless because time marches on, business operations grow and mature. Why should we bother, bottling the past and maintaining this backwards compatibility? Just bloats everything, creates enormous inventory, so much maintenance. And why should we needlessly hang on to something that is not true anymore? Because, in my opinion, we are using the immature technology, remote procedure calls, which require preconceived notions, preordained design. Now, Hateus, on the other hand, is what we call late binding. The calling client in Hateus knows nothing about the existing capabilities of the service provider, nor does the calling client even assume anything about the capabilities of the service provider. The calling client discovers the capabilities after it makes the call, not before. Same as when I, learned about how to renew my passport. I had no preconceived notions, but I was able actually to contact the government office. And only after contacting it, making the call, did I learn, okay, what is my next step? That approach is diametrically opposite from the remote procedure call approach, where the calling client must know the capabilities of the service provider before making the call. Otherwise, just can't even make the call. And it is for that reason that in Hateus, the inventory does not bloat and the accidental complexity is kept at bay. We don't need to maintain any versioning, and we don't need to worry about breaking the client. So we see that Hateus implements loose coupling. The calling client and the server are only initially coupled on the first first encounter. But that coupling does not need to be tight. It's very loose. Okay, just in general, show me in general direction, where should I go? First contact. All that the client needs to know is the location, the URL, or the capability of the capability that's to utilize. And the knowledge of the location of the subsequent capabilities is not coupled between the client and the server. That subsequent capabilities, those will be discovered in a piecemeal fashion as we back and forth interact. That knowledge gets revealed to the client once the server responds to the client's call. And I don't think it's impossible to implement looser coupling than that. It's really, really loose. And I think that Hateus mimics bureaucratic systems, at least how I see bureaucratic systems. Same as with the procedure to renew a passport. All that the client needs to know is the entry point, the first point of contact between the client and the service provider. From that moment on, once this transpires, the client is not expected to know anything, nor is it expected to memorize anything. And that's another big deal in taming the bloat, complexity, and inventory. Doesn't even need to memorize anything. Because the client remains stateless. And statelessness is desirable because it is less inventory. And actually in Hateus, both the server and the client are stateless, which is phenomenal. This is similar to how real-life bureaucracies function. They don't know anything about their clients' details beforehand, and the clients don't know anything about the service provider's details. Stateless, open-minded, beginner's mind. And, of course, as we go, we learn, we uncover, but not before. We don't go and study and make a career out of reading some, user's manual and figuring out. No, we do it in real time. Okay, that's all fine, but there is an elephant in the room, which I want to mention here because not everything is so easy and hunky-dory. And this elephant is the question, can machines deal with hate? So we've seen that hypermedia with self-descriptive messages and uniform interface enables us humans to piecemeal discover the capabilities of the app. And that's why the web is so ubiquitous and pervasive and the most popular platform, and really empowering, enabling us to improve our lives. But this only seemed to be innate to us who are literate humans who can read and write. And to us, it's intuitive. Like, we don't need to take a course to be able to, go and renew a passport online or something like that, some bureaucratic procedure. The question is, can machines intuit that discovery? And I think this is the key question here that we're trying to solve today. Because it seems like hypermedia is useless to machines. It's very useful to us, but to machines, it's kind of useless. And if that's the case, then it's back to the brittle RPC world. It's back to rolling with the punches and taking it on the chin and see, how can we deal with that pain? I want you to meet Carson Gross, whom I kind of been chatting with, and he's the creator of the HDMX hypermedia systems. Carson is a great guy. I consider him a thought leader in the field of software architecture. Very experienced, a lot of decades of experience, expert in his domain. He created HDMX.org, and it's kind of taking the world of web development by the storm. I probably exaggerating, but there's a lot of discussions around that, and it's a really good product, in my opinion. One reason is that it can drastically minimize accidental complexity. That's why people are starting to like it, because reducing the inventory, making our jobs easier, more pleasant, and lowering that pressure to deliver. Carson's mission is to enhance the original hypermedia as implemented via HTML tech. So he argues that HTML is only applicable to human users. Here I took the screenshot of from his blog post from like 8 years ago. So too long, didn't read. He says, HTML is actually a simple concept. Server sends both data and network operation on that data to the client, which has no special knowledge about the data. Okay, that's fine. This simple but powerful idea has been lost because it is typically examined in terms of machines and APIs rather than in terms of humans and HTML. Humans are uniquely positioned to take advantage of the power of HTML in a way that machines are not yet because they have agents. Humans have agents. All right. So in his essay that I linked here, he argues the following. But what I'm convinced of, and what I hope to convince you of, is that HTML is largely wasted on machines. HTML is for humans. So in my opinion, with all due respect, and I really respect him a lot, I think we may be looking at a missed opportunity. And yeah, if we follow that line of reasoning, we try something, should we give up? I would advise, let's try a bit harder. Maybe we are getting very close to uncovering something useful. So the question is, can machines process hypermedia? Without the ability to parse and process hypermedia, any calling client code is only safe if it's tightly coupled to the already tried and tested version of the app, as we've seen. If that's the case, our attempts to avoid brittleness and bloated inventory are defeated. And we cannot help but resign to those flaky, brittle remote procedure calls, back to the original pain. But I don't think it's necessarily true. There's no reason why machines could not parse hypermedia and detect in the self-descriptive messages what is the next available capability or capabilities of the app. So how to process self-descriptive messages? The only way to programmatically process self-descriptive messages, I think, is by severely constraining the domain of the client code. Server apps are never general purpose systems. We have different server apps, different verticals, but they're not general purpose systems. They're always narrowly focused on some business domain. A client wishing to interact with such services needs to be properly equipped with the knowledge about the domain. However, clients need not be equipped with the knowledge that describes how is the business domain functionally, how is that functionality implemented? Because that would mean if the client had to have knowledge how is it implemented, that is early binding, and that is brittle. Unlike general purpose hypermedia clients, business domain clients have narrow focus. General purpose hypermedia clients, what I mean by that's basically web browsers. They possess no domain knowledge. Web browsers are not opinionated. Web browsers know how to render any resource representation they receive from hypermedia servers. That's their specialty. And web browsers have no idea, nor do they care about the meaning of the resource representation. In a way, web browsers are like databases. Databases that, they specialize in storing data and manipulating, but they have no opinion about the meaning of the data. Web browsers indiscriminately interact with any hypermedia server, regardless of the domain that resource represent. A web browser is not going to argue and say, "Well, I refuse to render this. I don't think it's appropriate." It's going to just render whatever the server, whatever hypermedia server sends as a response. So I would say the clients that trying to implement Hateos functionality should be narrow purpose. If a client wishes to interact with hypermedia server, the client needs to limit that interaction only to clearly defined business domain. And I know it's kind of abstract, so let's maybe go walk through a concrete example that illustrates that. So let's say we have a situation where a client, this is the machine, the program, posts HTTP GET request. And that is basically driven from a user who wants to book a flight. Let's say this kind of hypothetical scenario, super easy, simple. How it goes about, of course, is the user first obtains out-of-band information. This is the first point of contact. Where is the online location of the airline booking service? And let's say it's airline.example.com. And then the client, the program, the code can send the HTTP GET requests to airline.example.com/flights/book. So this is the GET request. Then the server that receives that request sends back the HTTP response. And that response contains hypermedia controls that prompt for more information. For example, it could be HTML form that enables the input of necessary details, the departure and return days, the departure and arrival airports, et cetera, et cetera. We don't have time to go into those details today. So once the client receives that hypermedia control, it fills it out and submits the HTTP post request. The post contains the payload, the departure and return dates, the departure, arrival airports, etc., and is posted to the provided URL. Then it gets processed by the server. All these things I think are vanilla. Everybody should be able to follow. Now, once the server processes the response, it processes the request, it responds with available flights. I'm here going to show only one flight, but imagine there's like a lot of flights that kind of qualify, because I don't have the real estate here. So here's the response. Of course, there's a collection of flights, the 200 OK, HTTP response. And let's look at one flight. For example, number 12345, the departure date at the airport from YVR on June 1st, returning on 21st of June from Charles de Gaulle Airport. The price is $1,850, currency is Canadian dollars, and then there's some links here. So this is the self-descriptive message that the client, the program, or the code receives. So in here, we've seen that the link has a rel attribute. So I just want to quickly mention what is the role of that rel attribute. This is just vanilla HTML, nothing fancy. So the rel attribute, which is found in the subscript message, specifies the relationship between the current resource representation and the linked resource capabilities. In this example, current resource representation is the representation of the flight 12345 with all the attributes departures and the price, etc. And the linked resource capabilities in the REL are as follows. One is there's a capability to book a flight. There's a capability to obtain more flight details. And there is a capability to upgrade the flight. So I'm just going to go back to show you. So at the bottom, there's 3 links in the links collection, and they are all pointing at, airlineexample.com/flights12345/book or details or upgrade. All right. So let's say the client clicks on the books the flight 12345 by activating this link, sends the HTTP GET request to this link, airlineexample.com/flights/flight singular/12345/book. That HTTP GET request travels to the server, and it loads back, it responds with the HTML controls, maybe a form, or we'll skip the details, the gory details. So suppose the client then books the flight successfully by paying, etc., and now sends the HTTP GET request again. Says, okay, get me of all the flights, get me flight 12345 to the airline.example.com. Now, what happens here? It gets pretty much the same representation with same dates and everything. However, in the links section, now the book capability is gone because you cannot book a flight that's already been booked. However, it now offers the cancel booking capability that wasn't there before because you cannot cancel the flight that hasn't been booked. So you see, the self-descriptive message is exposing to the calling client what capabilities are currently available right now. This is the in-band information, right? The interaction between the client and the server is dynamic. Clients need not know in advance that the server has this capability, for example, to cancel booked flights. It's only exposed to the clients if the flight has already been booked and if the client inquires again about the capabilities of the resource. Similarly, many other changes to the server functionality get exposed to the clients at the last responsible moment. This is what we call lazy loading or late binding or loose coupling. So again, the open mind, the beginner's mind, not having preconceived notions, learning as we go. At the last moment, discover, oh, well, I can do this, I can do that, right? And then that means that if the server changes something, changes the syntax or something, the client doesn't break because it has no pre-baked expectation of a certain syntax. So knowing this, we can ask ourselves, can narrow business domains produce agency so that the machines can kind of back and forth between the server and decide what to do next? Because machines have zero sentience, no agency, no goals. And by narrowing the focus, we increase the chances of enabling machines to make correct decisions regarding what is the next appropriate action given the business context. And I'm thinking maybe large language models, machine learning could contribute quite a lot toward that goal, so that we bake in some vertical, some narrow knowledge of the business domain. I've been experimenting a little bit with specialized GPTs. You can create custom GPTs, train them on a specific vertical so that they have maybe a better grasp of the context. And these things are showing a lot of promise. However, these are still early days. That field is dynamic, definitely not showing any signs of slowing down. So things are improving. And there is a possibility that we can train some of these machines or clients to be able to understand, okay, given that my domain is booking a flight, then I can parse and understand what are the capabilities that are being presented to me right now and what is the meaningful action that I should take. Doing automation instead of expecting human users to do self-serve and decide where to click and what to do. So in summary, and I apologize for taking so long, I thought it was important to go through these steps. This is what I hope you learned today. What makes bureaucratic systems resilient, and why should we emulate them when developing software? I think there are two characteristics of bureaucratic systems that make them robust and resilient. One is statelessness. The other one is apathy. Designing automated systems to implement statelessness and apathy, or lack of eagerness for details, is the only way to achieve true loose coupling. And indeed, I think when we're dealing with bureaucracies, these two features are present. The apathy, it may sound negative, but actually good, because we're not wasting time on diving into some intimate details. We want to get something done. People who are working in bureaucratic systems want to get their job done. In and out, let's not dwell on it. Let's not waste too much time. It's very conservative and very efficient, in my opinion. And true loose coupling is absolutely necessary, in my opinion, for making our systems future-proof. If we cannot achieve loose coupling, then we lose this ability to have future-proof systems. And we know that as things change, we will have to go and rework our code. So the idea here is no need to rework. The client, the machine rolls with the punches. And if the syntax changes or there's some new capability or the old capability is gone, this client is not going to break. Okay, thank you very much for listening, for your patience. And let's see if we have any questions. Meanwhile, I will just put some of my details in case anybody's interested.
Thank you very much, Alex. Very interesting conversation, very interesting topic. I was just wondering where you were going with bureaucratic systems while we try to, bureaucracy always is associated with some stiffness. And so I was just wondering where you're going to go with this. But actually, what really comes out of this is really that loose coupling is still maintained here. And a week ago or last week, there was a Microsoft Build conference, and almost every single presentation, every second word was AI. And I was just wondering, what do you think? I mean, you mentioned this sort of, but where do you think AI is going to be in the future, or how it's going to actually help with the type of connections, APIs, interfaces?
Yes, thank you, Andrew. Yeah, AI, I believe, is good for trying to establish the context. It's showing some promise because. And again, the conversation itself in the bureaucratic system is stateless. We don't have to retain anything because all the information is in that self-descriptive message. But the narrowing the focus, right, and understanding that if I am, for example, filing a claim to WorkSafe BC, then the AI can be used to understand that context as to what makes sense, what is prioritized, what actions are should be offered to the calling machine so that they can accomplish the transaction without necessarily expecting self-serve from the human user. So that, I think understanding the business domain and keeping it as narrow as possible will enable the automation. Because right now, we are building those systems, but at the end of the day, it's driven by humans. We are sitting at it's like driving the car, right? We are making all the decisions, brake, gas, and we can because we have goals, we make those decisions. But I believe the AI can be trained, so long as we don't expect too much of it, and we keep it very on the straight and narrow, to represent the human agent and to go through these back and forth, simplifying the interaction without necessarily causing, car crash, so to speak, right? But like I say, it's still early days. I mean, OpenAI and LLM, but they're basically less than 2 years old, right? And we've seen incredible promise and incredible advancements, which I believe is going to keep going in that direction, where we can work with the machines, train them. I did some work with creating a custom GPT that you can kind of And, you know, it really requires domain expertise, I think. Somebody who really is master of the domain to sit down and work with the machine. And it all boils down to the quality of the input, I think.
Yeah.
The more specific and correct the input is, the machines are going to kind of shape into this ability to understand, not in sentient way, but at least to have the grasp of the concept of, I mean, it's debatable, but there is some research, and I don't have the quote here, but when children learn logic, there is some research that shows that it's very hard to learn logic unless you first master the language. And large language models are kind of in that direction. First, it masters the language. Once the language is mastered, then it's easier to have the ability to reason in a logical fashion. And the next thing is to understand the concepts of the physical world. I was doing some experiment with ChatGPT, and you give it a number of objects and you ask it, can you stack them up? And it can stack them up reasonably. It will not put ping pong ball at the bottom, and it understands the concepts of weight, of dimension, of stability, equilibrium. How does it know that? I think because it has good mastery of language. And so I think we need good experts in the domain who will train those machines. And to me, that is showing signs of promise.
Absolutely. Thank you. Yeah, the entire domain of discovery. Yeah, thank you. Any other questions from the audience?
I think Rod has a question, and then I also have a follow-up question. But Rod, you can go.
Hey, howdy. Yeah, I was actually totally impressed with the with the shift from my feeling of, oh my gosh, it's about bureaucracy to, oh, okay. What I was wondering about was, okay, I had my own doubts for, like some of the the human readable API stuff as well, for especially when it comes to like generating UIs or providing extra help and so on. And even from this one, I can see like you had like things for having the extra link tags that would come in if something was dynamically available, such as being able to cancel reservation and so on. So my question is, do you see that we might need to add extra like context files or special ways of writing that would be usable by the AIs, even for these APIs to actually work forward, and be actually useful for the automations?
Yeah, that's a great question. If you remember, I did talk a little bit about the rel attribute of the href. And that's very, very, very primitive. That was designed 30 years ago or even more. We are piggyback on it. The rel is kind of mentioning to the machines, hey, this is what you can do next, right? But I think we need more sophisticated markup encoding of actually explaining to the code or to the program what you can do next, what within this context is the highest priority. Because if you remember the self-descriptive message that I showed a collection of 3 links, and they were kind of, I don't know, are they sorted in the order of priority? How can the machine decide which one of the 3 I pick? The rel is just kind of, it's still very primitive, and you're onto something when you say we need more meta information or I don't know how annotation of some kind, that this self-descriptive messages, when it hits the client, it will be pretty clear right now what is the best thing you can do at this moment, right? So it can most of these interactions majority will be HTTP GET, where we say, okay, I say I can book a flight. Okay, HTTP GET, book a flight. It receives back the HTML, hypermedia control, where, as Andrew was saying, okay, so now what? Now within the domain, the system, you can train the system to say, oh, I see here, I can pick dates, I can pick airports, there's a drop-down menu, blah, blah, right? So it can fill out that and creates the payload, which sends it back. Now the server processes that, prepares the response, and if that response is sophisticated enough, sends back, oh, what about this? What about that, right? So now we are piecemeal discovering what is the next step in this process. Of course, when we are doing it in a self-serve fashion, when I was doing online registration, then yeah, we are literate humans. This is intuitive to us. I can easily grok what's on the page, and I can decide, oh yeah, no, I want to cancel this, or no, I want to talk to the representative, or blah, blah, blah. So machines are very far from that. Like they're very, very primitive state right now. But at least this system, this REST, is enabling the ability to not break when something changes. Now, whether by not breaking we actually accomplish that, or maybe we need to escalate back to the human operator, that's another question. And it could be hybrid. It could be machines are going up, back and forth, up until we reach a certain level, and then escalates to me, the master, or the owner says, okay, now you take it from here. I'm lost here. I don't know what to do, right? And that's fair enough. And I think that would be also, it's like a secretary, right? Fielding your calls, and it gets to the point like, excuse me, but I don't know how to deal with this client. Can you take over? Right? So the chores that are kind of, we humans should not be spending too much time. Okay, let the machines do them. But then there's always escape hatch that says, okay, I ran out of options. I don't know how to deal with this, right? But your question is really good, because you point out to the fact that we are currently at a very primitive state of this hypermedia. Carson has, if you go and follow Carson, he has made some progress with HTMX, but it's still early days, right? I don't know if this answers your question. As far as I can, the best I can tell you right now.
No, it does. Thank you very much.
You're welcome.
Hi. Alex, thank you. Thank you for the session. And as always, like I find it so knowledgeable, like your sessions. So just like on the specialized GPT, right, you were mentioning. So I recently come across 2 GPTs, right? One is related to travel planning, Expedia, which I have used. And kind of a lot of domain knowledge, as you mentioned, right? Like these will become more and more useful, like as they have more domain knowledge, and that again depends on the, I think, training and the data, right? Underlying data. And another one similar, like I did one course, product management. So there is a GPT especially for creating the PRD documents, right? Like who product managers creates in month. That can create like in few, I would say not in like hours, at least in 1 or 2 days, right? You can have full PRD for a product, right? And it can be just a brand new product which doesn't exist in the market. So yeah, thank you. Just wanted to share.
I just want to quickly mention this photo that I'm showing here. I attended this very interesting art show where the artist was actually stacking up some incredibly crazy objects and creating this very precarious balance. And the exhibition, I think, lasted for about 2 months. And it was based on these things would just spontaneously just fall. And then she would run and try and bring them back. And that really reminded me of our profession, where we've set things up, everything is in balance, and then all of a sudden something falls. So I thought that that's a very, very illustrative representation of how we go through our daily work. But it was a gorgeous show. It was fantastic.
Where was it? In Paris?
Yeah, that was in Paris. Last month I was in Paris. This is called Lafayette Anticipation. Beautiful gallery, free access, 4 floors of amazing artwork, and all these like really mind-opening concepts, right? And these people are fantastic. You go and talk to them, and they have all these ideas. The world is becoming a small place, and we're seeing the cross-pollination and hive mind happening everywhere. So it's really nice. It's exciting. And, I think we are at the forefront here, and especially in DevOps and pushing the envelope, we're at the forefront of trying to make our lives better, trying to make it more humane, more ethical. And that's why I appreciate, Andre, what you are doing and the crew here. running with DevOps, trying to build ethical software that helps humans, that does not impede us or hurt us, right? And I'm a big staunch advocate of that as well. Oh, I see there's a hand up.
Yep. Alan has a question.
Sure.
Hi, yes. How are you? I'm just wondering if the slide will be posted as well as the video. May I ask?
Up to Ilse and Willie. I don't know if you. I can send you the slides. I don't know how that works. Where would you post them?
We can post them. Or we can post the link on the meetup. So we are going to do that, and the video is going to be is recorded at this point. It will be posted about a month from now on YouTube in our channel. So we'll send the YouTube link in that in the meetup as well.
Right.
Okay, sounds good. Thank you.
Any other questions?
Yeah, I just have a question. It's my first time being in this meetup, and that's what I'm asking. If, for example, I think the next meetup is going to be a month from now, if I'm correct?
Correct. We always have it last Tuesday of the month. So the next one is coming in June, and it will be with Best Buy.
With Best Buy?
With Best Buy, yes.
Oh, within Best Buy. Okay, gotcha. Okay.
Yeah.
And then my question is just
it will be so we'll be on premise in their offices, and we'll be talking about that.
Yeah, because and so that's why I want to ask this, is simply because for the next meeting, how do you guys decide on the topics more specifically? Because I read the description of what was going to be discussed today, and it was I guess you can say a little bit different closer to the end, exactly based on the description. So I'm just curious, how do you guys come with the topics, and could we have any suggestions for what topics could be brought up next meeting and whatnot?
Well, that's exactly a great point, because that's one of the ask to our audience always. Every single meetup is to suggest the ideas that you would like to hear, and we'll try to organize some great speakers, as well as you can actually do yourself some presentations. So we are always looking for speakers and presenters.
Okay.
All right. Any other questions? If not, then Alex, many thanks for being with us today and presenting. It was a little bit at short notice, I know, but you, as always, you actually stand up to challenge. So thank you very much. Thank you very much for this. Thank you very much to all the participants. And it's always, again, as I mentioned, if there is any topic that you will be interested, please reach out to us, and please do not hesitate to contact us with any other topics or issues, or if you got some kind of a products that you would like to present that is related to DevOps, we'll be always happy to do that. So thank you very much, and have a great evening, everyone.
Thank you, Andre.
Thanks, Alex. It was really interesting.
Thank you so
Thank
much.
you.
Thank you, Alex.
Thanks, guys.
Thank
See you
you.
soon.
Bye.
Yeah, thank
Bye.
you.
Well done.
Thank you. Bye-bye.
Bye-bye.
Bye.